Hello students, welcome to the Master School Foundation program. Today we would like to discuss the very important topic that is regarding to the image formation by the convex lens. Alright, first of all you need to know about that image and its formation. It's very clear, we would like to go for that. Yes. Image formed by the lenses and lens maker's formula. We would like to use the lens maker's formula to get the object distance, image distance and all. Okay, it's very clear. You would like to go for this one. Yes, if you are going to get that image, while you are going to talk about that image, if you want to track the image, you have to construct the ray diagram. Alright, it's very clear. So, it has been formed. If you are going to take that, the reflected light rays or refracted light rays meets at one point to form the image. Alright, it's very clear. Yes, you would like to go for this one? Right. Yeah. Intersection of light rays after reflection. It's very clear. The light rays are going to be intersected. Just you have to confirm to track the image. Yes, you have to take that. This is very clear. You would like to go for this one. If you are going to take this one, just take that color. It's better to have that. After the reflection, they are going to. Yes, if you are going to get this one, that intersection point that makes the. Yes, if you are going to get this one, this is very clear. So, if you are going to identify that, refraction also, due to the refraction, refracted rays meets at one point forms the image. It's very clear. The rays or the incidented light rays are further moved after getting the refraction. They are all meet at one point. It's very simple. Just you have to confirm. They are going to meet at one point to form the image. It's very clear. So that you can, they will cut the principal axis. It's very clear. After the refraction, they will cut the principal axis to to form the image, and you can easily identify that the location of image and the size of image also you can talk. That depend on the position of object. It's very clear. If you are going to take this one, it's very easy for you. Just you have taken. It's very easy for you. The rays are going to getting this one. They are going to meet at this point. So, if you are going to take this one object and image, the refracted rays cuts the principal axis at one point to form the image. So, whether it is going to be virtual or real image, how you will define that? You can define the location of the object, location of the image. First, you have to take that the position of object. It will defines that position of image, where does it has been placed. If you have been placed between these, F and P, it's very clear, that is going to be virtual and is going to be the same side here. So the position of image is at the correct location. It's going to be here. Yes, if you have been placed here, what happened? You have to see. This is going to be like that. It's going to be virtual. This is the case we have to discuss. When does it will becomes virtual image? Yes, if you are going to get this one, this is the case, this is the case. These are all going to be the real images. Real. Just you have to take this one. Yeah, you have to confirm. This is going to be that image formation in case of the refraction. Reflection, you have been studied. Yeah, you have been studied that reflection. Just if you are going to get this better understanding, this is about refraction. Now you can take that reflection, it's going to be there. Yes. Yeah. The light ray is going to be just which is going to get this one. Yes, you will define that. Yeah, they are going to be appear. At the same time, you have to confirm it is going to be the real. Yeah, in case of that concave mirror, due to the reflection of light, it is going to form that real image. In case of the convex mirror, it's going to form that virtual image and diminished. Okay, just you have to take this is the convex lens. Yeah, that's what I am going to differentiate both the cases. All right, we are going to talk about this one. This is the concave mirror. Yeah, this is the concave mirror. Yes, you can take that real image. Yeah, here also you will get that real image. While you are considering that mirrors, the concave mirror is going to form the real image due to the reflection of the light rays. It's very clear. If you have taken that convex mirror, that is going to be having that virtual diminished image. But in case of the lens, while you have taken that convex lens, you can have the possibility, does it forms the real image? Yeah. Only the one case that is going to be except this one. Yeah, if the object has been placed here between F and P, then only there exists a formation of that virtual image. Other than when you are going to talk about this, when you are going to move from infinity to towards the pole, the size of image is going to vary. And you can define that it's going to be real, but while reaching this point, it is going to be virtual. It is very clear. We would like to go for this one. Generally, if you are going to take that, yeah, yes, you can take that. This is going to be F, this is going to be 2F, this is going to be F, this is going to be 2F. Yes, if you are moving from infinity to towards the center, just you have to see the size is going to gradually increases, right? Yes, you have to take that at infinity, that is going to be formed on either side. It's on either side of that lens, it's going to be real. If you have been placed here, F, there exists a formation of infinity. It is all about that image formation and its characteristics. Okay, this is about that the discussion how the image is going to be formed. All right, it's very clear. Right, when it is going to be real, when it is going to be, while you are talking about that real and virtual, if you are going to take that, all the refracted light rays meets at one point in the real space. So you are going to be having that real image you can track that refracted rays in the real space in the correct position. Is it possible? Then only it is going to be the real image. They will meet it somewhere else. In that case, we are not at all going to track that refracted rays where does it meets. That is going to be the imaginary. Alright, it is very clear. If you track the intersecting point of the refracted light rays, then it is going to be forming the real image. Yes, we will discuss, it is very clear. Yeah, you need to know about this one. Yes, okay, let us go for that. Yeah, it is very clear. Yes, image formation by thin lens you have to confirm, it is very clear. Yes, it is going to be the position and nature of image. They depend on the position of object and the type of lens that we are using. Right, we have to get that ray diagram. This is very clear. We would like to go for this one. Just you have to take that. How many number of lines? I am going to get that the minimum number of intersecting light rays. After the refraction, the minimum number of light rays to track the image, just you have to take that. This is going to be, yes, they are going to get that. They are the refracted 1 and 2. Yes, if you are going to take this one, this is easy for you to have that 2 rays minimum. You have to track the image with the help of the intersecting point of the 2 refracted light rays. So, in actual practice, we may show that many number of light rays are going to be refracted, but we are going to make it simple as 2 light rays. Very clear. Yeah, it is very clear. We would like to go for this ray diagram. Rules for the formation of image by the lenses. It is very clear. We would like to go for this one. Yes, ray diagram. To construct the image, what is the use of the ray diagram? They are useful to construct the image. Yes, it is very clear. It is the process to track the image by considering the ray diagrams. Alright, let us go for this one. So, just you have to see, this is going to be very clear, right, very clear. After the refraction, they are going to meet at one point. The parallel rays which are coming, which are originated from the source, after the refraction they will meet at one point, it is very clear. If the rays are incidented at different direction which are not at all parallel, after the refraction they are going to be parallel, they are about to meet at one point, they are going to be converging and diverging. Just you have to see, it is going to be identified, right. Yes, you have to take that this is going to be the convex lens, very clear. We are considering that this is going to be the principal axis, this is the principal axis. It's very clear. So, have you seen that this is very clear, you would like to go for this one, this is F2, yeah, second principal focus. So, you can, these are going to be the parallel rays, parallel incident light rays. After the refraction they will meet at one point, that is one case, okay. If it happened, they are going to be incidented through the center without deviation. Only the one possibility, that is you have that incident light rays which are parallel, alright. And if you are going to get this one, suppose you have been incidented, you can imagine this one, these rays which are going to be, yes, only the one ray which is going to be getting that without any deviation, alright. Just you have to see. What about next case? Yeah, you have to see in case of the concave what happened, you would like to go for this one. Yeah, the light rays which are going to be, yeah, these are incidented. After the refraction, they are going to be parallel. It's very clear. After the refraction, they are going to become as a parallel lines. Actually, they have to meet at this. They are appearing at F2. They are going to meet at F2. It's going to be the incident light rays are about to meet at F2. Actually, they are going to be refracted. After the refraction, they are going to be parallel lines. Very clear. You can confirm. In case of the concave, it's very simple. Third one, which is going to be that undeviated. It's going to be emerged out, which is directed to pass through the center. Just you have to see. Yes, it is going to be that undeviated. It's going to be unaffected. It doesn't get that any refraction. Emerged out without any deviation. It's very clear, which is passed through the center. It's very clear. Optical center, we would like to go for this. This is the undeviated ray. Yes, without any, no refraction. You have to get that, no refraction. Alright, it's very clear. You would like to go for this one. Okay, let's see if you have go for this one. What we have seen about F2 and F1, you can easily identify. Now we would like to go for that first principle focus. Yeah, you have to take this one. Yes, they are appearing from that. They are about to pass through this one. Let us assume. Yeah. After that, they are going to be, after the refraction, they are going to be parallel. What you have seen in the first case. In the first case, you have seen, if they are going to, they are incidented, this is going to be the principal axis. So, yeah, you have to confirm that is going to be. Yes, this is going to be F2. All right, they are going to be incidented light rays, they are refracted light rays, they will meet at F2. It is very clear. So, if you are going to get that, the light rays are originated from F1, first principle focus. They are appearing, actually they are originating from that F1. They become parallel. But if you have seen, these are the parallel light rays. After the refraction, they will meet at second principle focus. But in case of first principle focus, they are appearing as originated from F2. It is very clear. We would like to make it first principle focus, and this is the second principle focus. We have to confirm. This is very clear. Okay, if you are going to take that, these are going to be the parallel lines. It's very clear. Yes. After the refraction, they are going to be the parallel. If you have taken that parallel lines, you have been incidented the light rays which are parallel. After the refraction, they will meet at one point. Very simple. You can understood that concept of the convergence and the divergence. It's very easy. After the refraction, they will meet at one point actually happened. Suppose they are about to diverge from that point. You can easily understand that concept of divergence. All right. Okay, let's go for this one. Yes, in case of the concave, what we are going to get this one? It's very clear. Yes, you have seen that concave lens. Yeah, this is one. Yes. So, they are going to be incidented in this direction. After the refraction, they are going to be parallel. It's very clear. And they are about to meet at one point. You have to confirm this is one. They are about to meet at one point. That is going to be the first principle focus. But actually, after the refraction, they are going to be parallel, but they are about to meet at one point. That is going to be the first principle focus. It's very clear. We can define that first principle focus and second principle focus by this time. All right. After the refraction, where they actually meet, that F2, they are all about to meet at F1. Right, it's very clear. We would like to go for this one. Ray diagrams, just you have to get this one. It's very clear, very clear. Everyone has to see this one. These are the ray diagrams to construct the image. Yeah, if you are going to look into that matter of the first diagram, yes, you have seen that the first diagram, which is going to be representing that the incident light rays, the parallel rays after the refraction, they will meet at one point, that is going to be the F2. It's very clear. We would like to go for this one. This is F2. It's going to be F2. It's very clear. We would like to go for this one. Okay, at the same time, you have to identify that in case of the concave lens, what happened? They have been incidented. Yeah. So after the refraction, just you have to see, this is very important. The incident light rays are going to be in parallel in the first case, convex. Okay, the refracted light rays becomes parallel after the refraction. That was absorbed in case of concave lens. Alright, it's very clear. So if you are going to take that, this is only one case. It was undeviated. It was going to be the unaffected light ray when it passed through the center of that lens. Just you have to see optic center. Alright. Next, if you are going to get that, in the same case, if the light rays are going to pass through the first principal focus, after the refraction they are going to be the parallel lines. Alright, it's very clear. You have to see this one, this is going to be like that only. After the refraction, they are going to be the parallel. Okay, it's very clear. You have been observed this in case of convex, in case of concave. It's very clear. Alright. So, they are about to meet at this point. Actually, they are originated from F1, but here they are about to meet at F1. Alright. This is going to be that identification of that first principal focus. It's very clear. Identification of second principal focus also, you have to get this one. Easily you will confirm. Right. This is very clear to get this one. They have been incidented. After the refraction, they become parallel, but they are going to be the extended light rays which are actually meet at this point. By getting all these 5 diagrams, you can understand very easily how that image has been formed and its nature. What is its nature? Let's see. Let's go for that image characteristics of image and its formation. Alright. Yes, you can keep in mind just all you have to recap from the concave mirror and convex mirror. From the mirror to lens, what we have been identified the difference. In case of the concave mirror, what you have been observed. Yes, it will form, concave mirror forms that real image after the reflection. But if you are going to identify that convex mirror after the refraction, it is going to form that real. It's very clear. Yeah, except one case, right? You can take that. Keeping the above 3 points in mind, we can show that the image formed by a concave lens is very concave lens is always virtual, erect and diminished. Concave lens is always virtual, erect and diminished. It is very clear. Like convex mirror. Please all of you identify this one. This is very clear. Convex mirror. If you are going to take that convex mirror, always it is going to be forming that diminished image. It's going to be virtual, it's going to be erect. Very clear. Like that you have to reverse that case. In case, it was happened in case of the lenses, that is going to be concave lens. But while you have taken that concave mirror, it's going to be forming real image. Just you have to recap, that is enough. Right. While the nature of image in case of a convex lens depend on the position of object. It's very clear. Yes. Right. You can remember that convex lens, in case of the convex lens image formation, whenever you have been placed the object between the first principal focus and the pole, in that case only it will forms the virtual image. Other than that, it will forms the real image. Okay, it's all right. But while you are going to get this, you have been moved that, yeah, you have taken this point. This is going to be the F. This is going to be the 2F. Yes, F and 2F. Let's assume. Okay. If you are going to gradually, if you are moving towards the lens, initially let us assume the presence of object is at somewhere else. So they are going to be originated from that. The light rays are going to be originated from that infinity. We don't know. Might be the object is at somewhere else, that is going to be at infinity. We have to imagine. In that case, it is going to be getting that real image. Okay. Yes, you have to take that. It's going to be forming that image here. It's going to be right. Let's see. Yeah. For convex lens, image is virtual when the object between F and P. This is the case we have to get. Yeah, so very clear. We will discuss all these parameters very deeply, right? You can take that. That is only the one case. For the convex lens, image is virtual when object lies between F and P. In all other cases, it is going to be real. That is very, very important. You have to keep in mind. While you are going to answering the questions in entrance examinations, you might be having that little bit of confusion. You can overcome all the difficulties, no doubt at all. Only you have to identify that odd information. That is going to be that different. Except only the one case, that is when the object has been placed between the F and P, that is going to be the first principal focus and the pole. In that case only you will get the virtual image. In all the rest of the cases, wherever you have been placed from infinity to that F, up to the F, you will get the real image, and the size of image is going to be gradually increases. At one particular point it is going to be the highly magnified, after that it is going to be increasing, right? If you are going to moving, just you have to take this one. If you are gradually approaching that lens, what happened? The size of image is going to be increases, gradually approaching. It's very clear. What are the possibilities? We would like to talk about that. You have to get that 2F, this is 2F and F. If you are going to take that infinity to 2F, at 2F, between 2F, at F, these are all the different cases we have to take that. What happened? You have to see, right? Okay, let's go for that. Characteristics of images formed by convex lenses. Let's see the first one. Let us assume that the object is at infinity. Yeah, you have to confirm that the light rays are originated from that infinity. You have to see this is going to be that. The position of image is at F. You have to get that, which is going to be the real on either side of the lens. Just you have to confirm that the image is going to be the real. It's going to be the inverted. Yes, extremely diminished. You have to get that point size image. That's what we have to imagine. Extremely diminished means it is going to be having that point size, very less. All right. Okay. The position of object is going to be at infinity. Yes. If you are going to get this one, these are going to be interchangeable. Just if you are going to get that position of object is at infinity, image is at infinity. If you are getting that F, that image is formed at infinity. All right, you have to confirm. This is very easy for you to get that. Equal and same size, that is also identified. Yes, you have to take that. That is very important. Let's go for that. Yeah, you have been taken that. So the light rays are which are originated from infinity point, they are all going to meet at this one. Yes, you can imagine this is going to be the intersecting point to track the image. All right, just you have to see this is the image. It's very clear. Yes, you have to take that this is going to be that image. Very clear, the intersecting point which defines the position of image. All right. All right, let's go for this one. Have you seen, this is very important to understand that this is going to be the undeviated ray, this is going to be the refracted light ray which are going to have the intersecting point at A1. Okay, let's go for another one. So if the object has been placed between the infinity and beyond 2f, just you have to confirm at a finite distance beyond 2f. All right, just you have to take them at a finite distance. That is very, very important. What happened? You have to take that the image is going to be formed between f1 to f on either side. Just you have to take which is going to be the real and inverted and diminished. Just diminished means small size. Highly diminished means it's going to be the point size very, very less. Right. You can go for this one. Here we would like to talk about that position of image. Yes, that's obviously real, inverted, and it is going to be small, diminished. Just I am going to move, just you have to take that from infinity to 2f at a finite distance. Just you have to take this one. This is going to be the principal axis. All right, it's very clear. You have to define that f to f, that is going to be the first principal focus and the second principal focus. It's very clear. But the presence of object, it's going to be infinity to at finite distance. Here somewhere else, just you have to get this one. Here we would like to talk about that. Yes, okay, all right. Yes, okay, let's have look into that matter. One light ray which is going to be the undeviated. So one light ray has to come in this way, it has to intersect. All right, the intersecting point that defines the position of image. All right, it's very clear. You have to identify this one. This is very important to locate that image and to define the nature, which is going to be that inverted. All right, which is going to be the real. Very simple, just you have to confirm that real image. The light ray further proceeded by the refraction which cuts the principal, which meets the principal axis in the right direction, in the right place. That is going to be the real. If so, on another side, it is going to be the virtual. That was happened in case when you have been placed the object between the f and p. Okay, it's very clear. So for the present case, what we have to discuss, that is very important. Okay, when the object is going to be at infinity to 2f, that image is going to be formed between f and 2f, right? All right, let's go for another one. You have to get this nature. Right, okay, let's go for at 2f. What happened? You have to take this. Yes, you have to confirm. This is very clear. Yes, same size, which is going to be that size of image is going to be equal to size of object. It's very clear. When the presence of object is going to be at 2f, just you have to see. Okay, that is one. That light ray which is going to refract, after the refraction it will forms, and which is going to be formed as the same size, which is going to be the real and inverted, which of the same size. It's very clear. Yes, okay, we would like to confirm this is going to be that, this is the image. Yeah, we have to take that, that is going to be the object. All right, just we have to see, right, O and I. All right, yes, you have to take that. This is also one important. Yes, you have to take that at the C. Just you have to take, recap that image formation and its characteristics in case of the curved mirrors. It's very clear. Okay, right. Yes, you have to take that. You have further just the position of object is going to be changed, which is going to be approached towards the lens. Yeah, what we have between f and 2f, it's going to be here, let's assume. Yes, all right, we have seen that is going to be the object. Very clear. All right, just we have to see this is going to be that one undeviated ray to track the image. It's going to be right, it's very clear. We would like to get that there exists, it is going to be that image, it's going to be magnified. Yes, it's going to be that greater than the size of the object. Very clear, we would like to go for this one. This is one of the, yeah, from this point the size of image is going to be increased. Say yes or no? All right. Yes. So previously you have no at the C, if you have taken that mirrors, in case of the spherical mirrors, what you have seen in case of concave mirror, the object is at C, between C and F. Just you have to see, that is very, very important. Like that we have seen from, you have been placed here, from this point onwards its size is going to be increased, that is going to be magnification takes place. All right, it's very clear, real inverted and magnified, very clear, you have to get that. Next, if you are going to get that at infinity, the image is going to be at somewhere else but highly magnified, you have to confirm. They will meet at somewhere else, that is going to be at infinity. You have to take this one, this is very important, they will meet at infinity. They will meet at some infinity. This is the case we have to take. If you have been placed the object, this is going to be the object. All right, it's very clear at F. What happened? These rays are becoming parallel. At somewhere else they will meet. Just they are going to form that highly magnified image. All right, real, inverted and highly magnified. This is the case we would like to confirm. Just if you want, you can say that. It's very clear when the object is there like that. Yes, this is undeviated light ray which is going to pass through the center. Yes, you have to see that is going to, they are not at all going to meet at, they will meet at somewhere else. That's going to be at infinity. Yes, this is very clear, at infinity point they will meet, but it's going to be highly magnified. This is a special case we have to get. Now, what is the next case? You can guess it whenever you are going to move that between these one. You can imagine if you have been that image is formed that beyond that position, that is going to be that virtual. Yeah, we will see that. That's very clear. It's very clear. We would like to. This is only the case between lens and F. Okay, between, sometimes you may consider between the F and P, that is going to be the pole and focus. Just if you have been placed here, yes, you have to take that. This is going to be the object. Yes, this is going to be the image. Right, it's going to be image. I am going to confirm this is going to be the virtual image. Say yes or no? Because of its location, where does it has been formed? It's going to be in the right place or it is going to be in the wrong place. You have to confirm. Actually, the light rays which are further proceeded by the refraction actually meet at somewhere else, which is going to be in the real place, in the correct place. So this image is going to be that virtual image. All right, this is the virtual image. These are all the cases we have confirmed. Okay, student, we have that very good discussion that why it is going to be the real, why it is going to be virtual, how it is magnified, how the image is formed. Very clear, right? Just we have to take this is going to be the virtual and direct. All right. Okay, in the coming classes also we have completed all these possibilities and the cases. In the coming classes we would like to go for this one. Yeah, this is the chart, just we have to see this is going to be that 6 possibilities and having the case. This is only the special. Right. Okay, students, thank you very much. Have a nice day. Let us meet in the coming classes.